All right. Hello, everyone, and welcome to the first talk in Solution 1. My name is Fred, and today we're going to be going over new features in C# 11. So, who am I? I'm a senior software engineer at Microsoft. I've been a C# compiler developer for the past nearly 6 years actually now. And for that time, for about 4 years, I've been a language designer. So I've been on the C# language design team. The language design team is basically a virtual meta team composed of compiler engineers, IDE engineers, people from the base class libraries, people from big customers like ASP.NET, all trying together to make C# the best language that we can make it. I'm on GitHub at 333Fred. I'm on Discord. Normally, my handle is at 333Fred. My actual user ID is Uranus number 3333. And if you know where that comes from, do not worry. The ninth Shiner is not coming to this talk to obliterate all life as we know it. And I appreciate you for reading Garthnix. I am not on Twitter. If anyone has a blue verified check mark that claims that they're me, they've just paid their $8. I do not have a Twitter. All right. And before we go any further, there will be a Q&A at the end. It's going to be about 15 minutes if I've got my timing right. And you can ask questions either in Discord, in the Solution1 chat channel, or you can ask them here on your streaming platform of choice, and we will see them in our comment stream on our back end as well. All right. And so with that, let's jump straight into the demos here. You could go ahead and swap me. Thank you very much. All right. So this first feature that I'm going to demo is something that I'm super excited about because I submitted the first version of this proposal back like 2.5 years ago, maybe more. And it's been going through design and implementation, and finally it's ready here to demo for you. So as is tradition for most C# style, C# language design talks, I'm going to start with a person, right? A person class is a very simple DTO. It has a first name, it has a last name. And because I'm a good programmer, I'm a good C# person, I've been using nullable since C# 8. And so, of course, that means that first name here, I said in my code, can't be null. Middle name might be null. Last name can possibly be null. And to be clear, I'm working with US normal names, which have first name and last name. Other countries, of course, might not have a last name or might not have a specific section of these things. But middle name in most English names is possibly null, right? You might not have one. It's perfectly valid to not supply one. But again, because I've enabled nullable, when I go and I hover over this, everyone who's made an EF Core DTO or done something with reflection where you need to have a parameterless constructor and you're constructing these things via deserialization, you're familiar with this warning. Non-nullable property first name must contain a non-null value when exiting the constructor. Consider declaring the property as nullable. And I don't want to declare the property as nullable. Anyone who's constructing one of me should be providing a first name. They should be providing a last name. And unfortunately, I don't have that option right now, right? I can't look at this and I can't say, well, the person who's constructing me, they need to do it. And so you had a few options, of course. You could generate a constructor and you could initialize your parameters in, I didn't want to make that an optional parameter. You can generate a constructor and you can make those things set there, but now you're going to have to refactor all your code that was using object creation. And moreover, if you want to actually say have a derived type, like for example, I want to have students as a derived type of person because I'm actually representing a university of some kind. Well, that means for every parameter, I'm going to have to repeat the type once, and I'm going to have to repeat the name of it twice. And so, I want to represent professors, and those are also people. And now I have to do that again. And no matter how much of your IDE will scaffold this for you, it's still code that has to be maintained. Every time I add a new property here, I'm going to have to go refactor every single one of my implementations to pass another thing through. It's a real pain in the butt. And so that's why people have liked object initializers. And that's why we want to keep using them. Well, C# 11 finally adds the required keyword. So I can come and I can mark these guys as saying, you must pass one of these things in order to use this type. So I now get a nice error here that says required member person.last name must be set in the object initializer or attribute constructor. Right, so we look here and we no longer get warnings on first name and last name, and I get an actual error that said, yeah, dummy, you weren't initializing this thing. And that I initialize that thing and it goes away. And then when I want to make my student class, I just say public class. Student, person, and no more boilerplate is required. That's it. We're all done. I didn't have to pass through anything. It automatically inherited all the required members of the base type. Perfect. Okay. You might have noticed the other thing that the error warning said, that the error said, is attribute constructor. Well, the reason that's there is because I can also make attributes, and I can set properties in attributes. And so here I can do that, and now I can also enforce my properties be set via attribute constructors as well. So again, I'm super excited to bring this. I've been working on it for a long time. So I'm really happy that everyone finally gets to have it in place. All right, let's move on to the next demo. For this one, I'm not going to go too much into the design of the math interfaces. Tanner is going to go over that in the next talk. But let's start with, I have an add-all method. All right, I'm taking in some array of strings. I have 1, 2, 3, 4, 5 as strings. I'm taking them in as an array. I'm for eaching the array. I'm calling int.parse on these things to get the number out, and I'm returning the result. And that's great. This is all integer based. Okay, so I publish my library with this method, and then someone else comes along and they say, hey, I'd really like to do this at doubles. And then you say, okay, fine. I will copy this, I will paste this, and I will replace int with double. Okay, and then I'll disambiguate the name so that I can add it. All right, and then someone else comes along and they ask you for long, and then someone else comes along and they ask you for decimal, and someone else comes along and says, hey, I have my custom imaginary type because I'm working with EE things, and I need to talk about AC, and we use imaginary numbers over there. So can you please support my imaginary number library? And your head explodes and you don't want to do it anymore. Wouldn't it be great if we could abstract over these things, right? Ideally, in an ideal world, we'd be able to make this generic. And we'd be able to say, I have a T, and that T is going to somehow know how to parse things from a string. And all you need to do is specify this T value, and then it will work for any number. Well, C#11 and .NET 7 have added a new set of interfaces. Again, Tanner will go over these in more depth later, but the very cool part is that these interfaces introduce static abstract members. And so when I look at this here, suddenly this parse is actually getting resolved to a real method. This plus is actually getting resolved to a real method that is defined on my T. So if I go to iNumber and I look at this, we see a whole bunch of interfaces, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and I'm not even halfway through these interfaces. There are so many of these, but number itself, iNumber, says I am a number type. And so now, instead of saying 0, I have to say something, whatever defines the 0 for this interface. So T.0 is a thing that is defined on iNumber base. If I look at parse, parse is a method, an abstract static method that is defined on ispan parsable. If I look at the plus, that is a static abstract operator, which is defined on iAddition operators, right? And there's no more errors in this method. It kind of just exists. And so if I specify here that I would like to parse these as integers, and I go ahead and I run my code, well, now it's 15, which is actually correct. You know, 5 bang is in fact 15. And what if I wanted to parse these as doubles? And just to prove that it's a double, I'll make that 1.1. We'll run again. 15.1. Oh, you can't see this, can you? Because it's, let's minimize those. All right, there we go. Now you can see it, 15.1. Just to make sure, I'll switch this back to int. So you can get to see that one run. There we go. All right, so that's really cool, right? Because we're using static abstract values. We're saying that this is a type parameter, and that type parameter can be parsed. It knows how to parse. For a long time in C#, we've had the ability to say, I can be formatted, right? Given an instance of me, you can turn me into a string. All right, we've had that for a long time. But what we haven't had is the ability to say, given a string, you can make an instance of me. And that is really powerful. It's something that we haven't had in C# before, ever, right? We've never had this ability to say, given a factory method, given a type parameter, it's a factory. You can actually define a factory here in a generic fashion and not need to pass around instances of your factories that are generated by other factories. It can be entirely generic based, entirely clean, and it's a level of new expressive power in the language and the runtime that is pretty amazing. We haven't had a change this big in the expressive ability of C# in a long time. It's at least as big as async await here, possibly even just as big as going back to generics. And so this is a feature that, the BCL's mainline use for this is iNumber. It's all the numeric interfaces. But I'm really, really excited to see what everyone else does with this feature, what you all come up with, what factories you end up using. That's something that we're going to be looking at as part of C# in the future, is we're going to be looking at better ways to compose and construct things. This is our intention of how we're going to eventually make WhereT new better. So we are really looking forward to seeing what you all do with it. All right, moving on to another feature that we've been turning the crank, as we say. Every new feature that we have, that every time that we come up with a new C# language, since about C#7, we've added a new feature. And so every release, we've turned the crank once more on patterns. And so C#7 added very simple declaration patterns that you can use in is and case statements. C#8 added recursive patterns. C#9 added more. C#10 added even more. And so we are back once again in C#11 with another new pattern. And so we're going to try and rewrite this add all method using a pattern version instead of using the imperative for each version. You probably wouldn't write it like this in reality. You'd probably just use the for each loop. But the use case for this feature is much broader. And it's especially useful when you're working with trees or working with subsets of lists and you need to quickly jump around them. So what we want to do is we want to say, because we're using patterns, and so the key component of patterns is either the switch statement or the switch expression. And okay, we have cases that we need to handle. The compiler helpfully says, hey, you didn't handle all the possible inputs. For example, the any pattern at all, which is the underscore, is not covered. All right, what's our first case? Our first case is going to be length 0, right? And so for those, we want to do p.0. But this isn't a very great pattern because, okay, it's length 0. What am I going to have to do for length 1? I'm going to have to say that length is 1, and then I'm going to have to go into this input and pull stuff out of it, and then I'm going to have to do that again and again and again. And so what we've done in C#11 is we've added a new list pattern to match on things that are list-like. So arrays are list-like. Obviously, lists are list-like. And this is very similar in syntax to array access and array subscripting. So if you go back to C#8, where we added indexers and we added ranges, the syntax here is very much inspired by those. So we look at this, and they all operate on things that can be indexed. So we look here at this empty array, and this says, if the thing has no elements, we want to return a 0. Okay, so now we look at our switch and we say, okay, for example, length 1 isn't handled. Okay, so now I need to go handle my length 1. And so what I can put inside this list pattern is I can put any pattern. So if, for example, I wanted to say handle 1 in a specific fashion, I could do that if I want. That's a constant pattern. I can do, if this thing, if it was a number, for example, I could say if it's greater than 1 and less than 10, right? It's not a number, so I can't use number patterns on it, but I could. In this case, I'm using a declaration pattern because I don't care what the first string is. I just want to pull it out. And then I want to say, again, t.parse on that first. And then I want to call culture info.invariant culture. Okay, I've handled my first case. And again, I go up here and it says it's not exhaustive. And so, all right, it says I need to handle 2. So I'll go var second. And then I guess that means I need to just add another plus here and change that to second. And then I go up here and I look and it tells me that length 3 isn't. And I keep going and keep going and keep going. And, the compiler will make sure that you handle every possible input. And so your fingers may fall off typing all of these out before the compiler gives up and says, you actually have handled everything. Wouldn't it be great if I could just say, capture the rest of everything and do this recursively, like a good functional programmer that I am? And you can do that. This is called a slice pattern. It's the ... Much like slicing in ranges, again, getting back to what the C#8 feature, you can slice and then you can capture that slice. For some slices you can't capture, depends on the type in question. If the type itself is sliceable, then you can use a slice pattern on it, and arrays are sliceable. So I can capture the rest into my pattern here, and then I can just recursively call rest. And now I have parsed the first number and then add it all to the result of parsing the rest of the numbers. Now, some of you there are probably a couple of things that people are going, you could do this a little bit better. And there are a couple of things. First, if we look at this, well, the slice pattern says, give me the rest of it, even if it's 0. And the compiler will helpfully point out to me if I reorder these things, that actually this case here, var first and give me the rest, handles the single element array. So I can actually remove that entirely. And now we just have we have our simple recursive algorithm that has a base case and the other case. The other thing that people might be going, no, is when you slice arrays, you allocate a new array. So when I look here, that is in fact a string array. So we started off with 5 elements passing into this thing. Then we'll go down to 4 elements and make a new array for those 4 elements, and then 3-element array, and then a new 2-element array, and then a new 1-element array, and then finally a new 0-element array. And that's a waste of space. And so what we can do, if we really want to optimize this, is we can say that this thing is a read-only span. And read-only spans are also list-like. So we can look at this and we can say, yes, it's sliced and it's a read-only span, and those are incredibly cheap to make. And so now we have our very nice read-only span based slice pattern, and we look over here and it does in fact print the 15 that we were expecting. All right, so that was numerics and that was list patterns. Let's go ahead and move on to the next demo in my talk, which is going to be about raw string literals. And for this, I'm going to turn on white space so that we can all understand what type of white space I'm talking about here. So when we do, and I will also quickly switch the startup program. So when we put strings in C#, we know that we're going to have to escape content in some fashion, right? For a regular string literal, I'm going to have to use a backslash to escape my quotes. And the value that shows up in the debug console is not the same as the value that I've had in my text, right? When I look at this, it says, okay, there's a backslash here, there's no backslash here. I'm gonna have to parse that in my head and go from one form to the other, back and forth, across the debugger, across the console output. It's not great. We don't like that. Verbatim strings are a little better in some aspects, but they don't actually solve the quote problem, right? Because now I need to escape my quotes with double quotes. And so if I need to double quote something, suddenly that means I need 4 quotes in this thing. And then I have to mentally, okay, count those quotes. And I don't know about any of you, but when I'm counting 4 quotes in a row and I'm looking at that, my head starts to spin, and it takes me a second to count that there are actually 4 quotes there. So what we tried to add in C# 11 was the last string format that we are going to need, the last literal format that anyone will ever need in C#. And that's the goal. And these are raw strings. So they start with 3 quotes and they end with 3 quotes. And when I run, we can now see that the backslash is included in the content, right? There is no escaping, no interpretation of the values inside the string. Now, you may be going, all right, but what if I need 3 strings? What if I need 3 quotes in my body, right? You said it was the last one I'm ever going to need. How do I do that, right? You can just make it 4. And now I can have up to 3 quotes in my content. And so when I run this again, there are 3 quotes in my output. And you can keep doing this, of course. Okay, I need 4 quotes in my content, and I can make 4 quotes and I can make the limiters 5 quotes, and I can keep going and keep going and keep going as many times as you want. Eventually, your computer will run out of memory, and the compiler won't be able to compile your program. But I mean, if you had an infinite Turing machine, then this could, in fact, work ad infinitum. Okay. Another problem that people have with strings today is we don't like how this is all on one line. This is a very simple XML literal, but you might have, for example, some complicated JSON that spans a whole bunch of, some JSON object that spans 100 properties. That's not all going to fit on one line. And so we need to use verbatim strings for that today. And everyone has some gripes with how verbatim strings render. So let me put this onto some multiple lines. And when we look at this, of course, if this were a verbatim string, change this to a verbatim string real quick, and don't escape that. All right. When I run this, of course, we have a new line here. We have this new line specifically, and we have a new line at the end, actually. We have this new line. Now, maybe you take the option of trimming your strings, but that still doesn't get rid of the other problem, which is, well, I'm in a method body, or I'm in some nested content, and I have to left indent my string all the way to the left edge of the file. Otherwise, when I run, I'm going to get these 4 spaces actually in the contents of my string, and I don't want those. And again, maybe you can write some helper that de-indents every line and removes the trailing strings and the leading new line, and that just sucks. No one likes doing that. So verbatim strings tries to solve both of these things. So first and foremost, when you use a verbatim string, or not verbatim string, sorry, raw string, and get rid of my double quotes there, and I go ahead and I run this. When we look at it, there is no leading new line, right? That is just the debugger, and then immediately the content. No leading new line, no trailing new line. That's it. So the raw strings will automatically remove that leading new line, and it will automatically remove that trailing new line. Importantly, if you put a new line there, right? If you specifically want this to have a new line, you can do that. It only removes that first one. This second one here, that new line is actually part of the string's content, and same for the end. If you want to have an actual string, you can have it. All right, so another thing that you might want to have is you might want to indent your code again, right? You might want to not have this thing slammed all the way to the right side all the way to the left side of your screen. removing the flow, making things look odd. Well, you can do that as well. If I run this code, we're going to see that, in fact, the trailing spaces, or the leading spaces, were removed from each line. And the way this is controlled is where this string end is located. So there are currently four spaces at this line. So there are 4 spaces that are removed from each of the other lines. So if I were to remove that, and I were to say there are only 2 spaces, and then I were to run this again, there are now 2 spaces at the front of the line. So you control this, and if, for example, you have too many spaces and some content starts before this, you'll get an error that says the raw string literal does not start with the same white space as the closing line of the raw string literal. And so these need to match up, and if they match up, then everything is good. And again, I said this was going to be the last format you need. And so what if I need to interpolate something, right? I have some content, and it's a string that says hello world, okay? And I need to put it inside the body here. And so just like other strings, we support interpolation. And so you can say body here, and then run it. And we go ahead and run, and we see there is, in fact, hello world. And of course, you then go, but I need to put some braces in the body of this thing. I want to be able to surround this thing with braces for some reason. Maybe, for example, you're trying to interpolate JSON, right? Maybe you have some JSON literal and you want to fill in values, and you need to have the braces in them. We run into this all the time in C# when we need to write C# in a string in C#, and we want to interpolate into that C# string, which has braces in it. Well, you can control that by the number of $signs, much like you can control the number of quotes by the number of quotes. So now you can see here with $2 signs, $2 is what starts the interpolation. So if I want to have braces and I want to have an interpolation inside those braces, I can do that. And now we have one set of braces and the interpolation. And now you say, well, actually, I want to have 3. I want this to be rendered exactly as is, and I want to interpolate in some other fashion. Well, now you can say 4 quotes, and now you can have 3 braces as content. And so again, the goal with this string, with the string format, is that no matter what input you have, no matter where it's coming from, what type of content is in it, there is a form of syntax you can write here that will allow you to write that string and paste it as is into C#. No more need to maintain, okay, when I paste it in here, hopefully my editor escapes it for me. Maybe it does, maybe it doesn't. When I paste it in here, and then when I take it from here and I paste it into something else, I need to unescape it manually. None of that anymore. It's just what we have, what we see is what we get. And this form right here, $, quote, 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 is one of our favorite new forms on the compiler team, of course, because again, we have to write C# tests in C#. And so that means we need to put C# into strings in C#. And so this allows us to actually write, class and say have actual content inside the body of our classes. All right. And for the final demo that I wanted to talk to you today about, I want to go over file local types. All right. So I want to go in order to go over this, I want to go over quickly source generators. Source generators allow analyzer authors and library authors to provide functionality for you by generating code into your project. And so one of the things that happens with this, for example, in shipping as part of the .NET 7 is the regex generator. And so I can have a partial method and I can put a generated regex attribute on it that says, hey, I would like to match this regex string. And then I go to that regex and it will generate all of this stuff for me. And it does, they put a ton of effort into generating this code very nicely. So you look at this and it says it's well commented, it's idiomatic code that you would write. And this lets you have your cake and eat it too when it comes to regexes, because previously we've had 2 options for a regex, right? You can either compile them ahead of time, or you can either interpret them at runtime, or you can compile them at runtime. Interpreting them at runtime is slower, but it has less startup cost penalty because you don't have to compile something at runtime. And the compiled version is slower to start up because you have to actually compile it at the start of your program, but it's faster to actually run because you're not interpreting the regex and parsing it as it goes. And in both of those cases, you need to actually parse that regex at runtime, right? The compiled version needs to parse it at runtime. The interpreted version needs to parse it at runtime. And now you can actually generate that code at compile time. And so you look through here, and we've got a sealed class that's a private instance that's actually the implementation, and you go through, and it has the runner, and it has, again, they've done a lot of work into making this idiomatic code that you can read and understand what it's doing and step through. But the thing about that code is that it's an implementation detail of the regex generator, right? Unfortunately, when I start typing my regex, I have the file feature turned on. No. There it is. Just took a moment to generate the import completion cache. All right. When I start typing this, even if I don't have the thing imported, Visual Studio or VS Code or Writer is going to helpfully suggest, hey, there's this thing that you can call, and you can get an instance off of it, and you can do stuff with it. And that's an implementation detail of this generator. If they change that code, right, if they make it start generating something different, well, that's a problem, because your code, which took a dependency on the way that generated method works, now it's suddenly broken after you update, and they don't want you taking an implementation detail on it. What they want is for you to call myregex.matches, or you need to call that method, and that's how you get an instance of it. Another problem that runs into is, what if I define my own myregex_0 class? Now I look at this here, and if I generate it in the right namespace, of course, now I get an error that says it already has one, and I get an error over here. And that's not great. Again, exposing implementation details. Normally this stuff is hidden behind another DLL, right? It's a private type or an internal type in a different DLL. Excuse me. In a different DLL that you don't have access to, and you can't depend on it. And so what we've added mainly for generator authors in C#11 is the file keyword. And so file says this thing is a private file type. It is not visible outside of this file. So when I go over here and I start typing out my regex, it doesn't appear in the list. When I type 0.instance and I actually look at this, it says my regex_0 does not exist in the current context. And so that is actually how the regex generator works. And let me go ahead and delete this file, because I've been using trickery to not use the real regex generator. And now when I go to the real regex generator, this is the actual source generated content, we can see that it is, in fact, using the file keyword here. All right. So that is all I had for demos today. So let's go ahead and switch back to the slides so that we can go over the future. So I wanted to close out by talking about some things that are coming to a C# version near you at some point. I can't promise what specific version of C# any of these are coming to, but hopefully sometime soon. So the first thing that I wanted to talk about is roles and extensions. So let's assume for these next couple of slides that we have a class that looks like this, where we have a data object, and that object is, you can think of it as deserialized wire data. Maybe it came from JSON, maybe it came from YAML, maybe it came from XML. However it is, whatever it is either it potentially has some amount of named value pairs inside of it as a dictionary. It might be possible that this data object is in fact just a string. It might be possible that this thing is an enumerable, and it might have an ID. So it could be an array, for example, for the enumerable case. And what we would like to do, and what you can do today, is you can define a toJSON extension method on data object, right? You can have a static class that's JSON data object, and it provides a toJSON. And that can then serialize this into JSON. No matter what format it came in, you can get it out as JSON. But what you can't do today, and what people have been asking for quite some time, is the ability to define a static extension method here, and define it and say, I would, given a data object I can get from JSON. Today you have to make that a static method on my JSON data object class, but roles and extensions are going to provide the ability to actually define extension everything. And so that means static methods. So all those methods that you've been wanting to add to the math class, but you can't because you can't put an extension method on a static class, you'll be able to do that. And so in this case, we're adding a static method from JSON to data object. So you can say data object from JSON, and as long as the namespace that defines this extension is in scope, like any other extension method, you'll be able to call that as if you were calling it, as if it was natively defined on data object. So that's an extension, but what's a role? Roles are more like a lightweight subtype. So when we look at this role, maybe I have a specific data object, right? I called an API and it gave me a list of things that I know are customers, right? It gave me as perhaps JSON or whatever it returned as, it gave me some wire data that I know has a name. I know it has a name property, and I know that property is a string. I know it has an address, and I know that property is a string. And I know that it has an orders property, and that set of orders has its own set of things. And that orders property is an enumerable of those sets of things. Well, what I can do is I can define a role. And a role is, again, an extension thing. I can all of these operators appear as if they natively exist on data object. But unlike extension, where everything is implicitly, it just happens, a customer only gets applied when I decide that actually this thing, I know it's a customer and I want to opt it into it. And so an extension is, again, for all data objects, and a role is a specific version of it. It says, for this particular instance, I know it's a customer, so please let me access these things. And again, these are things you can't do today, right? Extension properties, you're not able to do that. Augmenting having extension methods only appear on specific instances of a type, again, not something you can do. So we're really excited for roles and extensions. The plan is that someday they will even be able to do interface implementation. So you can view a data object as implementing some interface the data object doesn't have, and pass it to methods that expect one of those interfaces, and have everything just work. All right. Another thing we're planning on doing is some property improvements. So in particular, those of you that do MVVM and use any of the MVVM source generators are going to be very happy with these. We are planning to have partial properties. So you can say partial prop and then have a declaration, and then have a behind the scenes generator actually generate you that property. Today, most of the generators that I know of use the field keyword, not the field keyword, use a backing field instead. And backing fields aren't great when you're doing MVVM. Just the other day, I spent 5 minutes staring at the screen wondering why my view wasn't updating when I set a property, only to realize I actually wasn't setting the property. I was setting the backing field. INPC was not actually being called. Nothing was being notified. And so that's what the other thing that we're looking at, semi-auto properties, will address. And semi-auto properties lets you bridge that gap, where today, if you want to actually say, I have a property, and the only thing that's special about it, it's going to set and get from the field. The only thing that's special about it is I want to throw if you provide me an invalid value, or I want to call my I notify property changed handlers after I set the value. What this will let you do is it will let you say that. So it will have this new field keyword here, and that new field keyword will exist inside properties, and it will let you set the backing field, which is only visible inside the property. So you're never going to have to worry about people or yourself accidentally setting a field instead of intentionally setting the property and not triggering your INPC. All right. Next, we're going to have Lambda default parameters. This one was actually just merged. One of our interns over the summer worked on this, and then it was finished up by Jan Jones, who was one of the new members of the compiler team. And this feature is inspired by the work that we've been doing on minimal APIs. And the idea behind this feature is that with minimal APIs in C#10, we added the ability for lambdas to do almost everything that a regular local function can do, right? They can now have return types. They can have attributes on parameters. They can have natural types. So you don't need to say this is an action. You can just say var. What you haven't been able to do is you haven't been able to specify default parameters. And so if you had, for example, a route that had an ID required parameter and you had a task secondary parameter that it's optional, well, what you need to do is you need to actually either define a local function to do that, or you need to use one of the ASP.NET's attributes to define that. In C#12, hopefully you should be able to just say string task equals foo in your Lambda, not need to break out into a local function for this case, and everything will work just fine. And also, it will support params. There will be some param support for this as well, not just default parameters. Another one that we're looking at is collection literals. So other languages have easier ways to define collection literals, and today in C# we have object initializers. Those don't work for every type. For example, immutable array, if you can use an object initializer with the immutable array, it's just not going to do what you want it to do. And you'll be very confused about why it's actually not doing anything. Another problem with collection initializers is that they're not as efficient as the code that you could write, right? You could allocate backing storage to start with. Yeah, I know that I'm starting with 2 values here. And so I can tell the list constructor, hey, you need to have a space for at least 2 values. Or I know I'm starting with 10 elements. And so you need to have space for at least 10. And that's a lot of code to write. You have to keep the number that you're passing in sync with the number of things that you're passing to the add methods. It's a lot of work, and many people just don't do it. And so the goal with collection literals is that we are going to write as efficient code as you could for most cases. We're not going to be perfect, but in most cases, this is going to be the best way to give yourself a list or an array or whatever. So the natural type at the moment we're thinking of these things is going to be list for lists and dictionary for dictionary. But these things will also work with target typing. So you will be able to say immutable array of string is equal to this thing. You'll be able to say array of as my string array is equal to this thing. Whatever type you have that is list-like, you will be able to create one with this pattern, and it will be as efficient as it can go. All right, some other active topics that we're working on: discriminated unions. Sorry, I don't have syntax examples for this. We're still in the active design phase, but it is something that we're looking at. I know it's the most popular requested feature on C# Lang. I want it to. We are trying to bring it, and it's just a big topic space. All right. And one of the other things that we're looking at is question null conditional assignment. So previously, you've been able to say question equal assignment, which says if the thing on the left is null, don't assign the thing on the right, otherwise assign the thing on the right. And now what you can do is you can do question dot assignment. And so what this says is if C is null, don't do anything else. If C is not null, create a new object and assign it to C.obj. All right. And so where you can find out more information about all this stuff, github.com/.net/C#Lang. This is where the language design happens. I post notes there after our LDMs, our language design meetings. Those happen generally every Monday and Wednesday. You can find the schedule in the meeting section for a particular year, and it will list what the upcoming topics are. You can also look through our historical notes, I believe all the way back to 2013. I've been taking the notes and posting them since late 2019, early 2020, somewhere in that time frame. You can also post topics. You can participate in discussions on new language features. Suggest one if it hasn't been suggested already. Feel free to come talk to us. We are happy to discuss on that forum. You can also come find the compiler and the implementation details on github.com/.net/Roslyn. And of course, the C# Discord, discord.gg/C#. A number of language designers, including myself, are often active in the Roslyn channel on the C# Discord. So if you have C# questions about the language design, or questions about source generators, or questions about Roslyn in general, we are more than happy to talk. We love to talk to people. Come and talk with us. All right. And so with that, that's all the content I had for today. And so let's go ahead and get some questions. And Max, I'm assuming that you were going to be asking me these questions. I wasn't planning on collating for them as well. All right, I guess I'm going to be reading them out. All right. So questions, again, you can ask them either in the Solution1 chat in the Discord, or you can ask them in YouTube, and I will be looking for those as well. So Thinker asks, what feature am I personally most excited for? That's a hard one. I'm really excited for discriminated unions, and I'm really excited for roles. I think those are my two most favorite of the things that we are happening. So Tio asks, in the generic math example in the beginning, I wonder why parse is resolved to parse method on ispan parsable instead of iparsable. Good question. Max, could you please switch me back to my code? All right, so if we go back here, so the way that method overload resolution works in C# is it walks up interfaces, and it's worked this way since C#1. It walks up to interfaces and derived types. So the first thing that it finds, the first type that it finds that has methods that match by name, it looks to see whether any of the methods in that type are applicable. And if they are, it stops looking. So in this case, ispan parsable inherits from iparsable. So when the compiler is attempting to do overload resolution, it sees parse, it looks at T, it looks for parse methods in T itself, and it keeps walking up until it finds something that works. And in this case, again, ispan parsable inherits from iparsable. And so that means that it can just, it will stop there. Even though you might say iparsable dot parse is more specific because it takes a string. This one is found first, and so it stops looking. All right. We have a question from Cow. What is the hardest feature to implement in C# until now? I mean, I wasn't here prior to about C# 8, so I can't answer anything prior to C# 8. But Nullable has definitely been, since I've been on the team, the absolute most work we have spent on anything. I think we calculated it out to be 25 person years of work in just the compiler. That's not including the work in the BCL. That's not including the work in ASP.NET. It's not including anything else in any of the other libraries. 25 years of work in just the compiler team, all hands on deck, all of us working on Nullable for several years. So that's the hardest one I've experienced personally. All right. Repeated Z's asks, any plans to make list patterns somehow work with strings or span of T? I showed it working with both of those things. Well, I showed it working with span. I did not show it, if you look right here, this is a span and it's working. And it will also work with strings just fine. So I can say, for example, this is a string, so I can say, give me the first character and a string, right? So I can look at this, that's the first character, this is the string that is the rest of it. Right, that just works fine. All right, natively supported void generics on the table going forward from Sosenbinder. I'm guessing what you mean by this is void going to be a first class type? Can I put void? Can I do func void? Can I do those types of things? I wouldn't say never, but I would say it's not something we're actively looking at the moment. I would love to have a native unit type in C#. but unfortunately, it's not on the table at the moment. More questions. If I missed something, please ping me. I did not. Oh, there's one up here that I missed. In TypeScript, I often use an interface to deserialize JSON without ever implementing that interface. Is that sort of what a role is? Yeah, it is. It's a lightweight view. A role, one of the use cases that we view for roles is a lightweight view on data types. Wire data is one of the things we're looking at most strongly here. Many of you may know of roles via the Shapes proposal. It started out as Shapes a long time ago, and since then has kind of transformed into roles. Shapes was much more implicit. It lets you say if it quacks like a duck, it is a duck. Roles, you need to actually specify what it's extending. It's not implicit. But that's still the idea, is that you don't have to deserialize everything. It's a lightweight view on something. Tio asks, will roles be able to implement interfaces? Yes, that is in fact one of the things that I am most excited for about roles, is that they will be able to implement interfaces. And so what that really means, putting on my language nerd hat for a moment, is that means type classes. If you're familiar with Haskell, if you're familiar with associated types in, or if you're familiar with traits in Rust, if you're familiar with protocols in Swift, roles are how we're going to get to that type of expressiveness. So I'm super excited for those. So Tobacco asks, we're seeing everything work perfectly in VS Code. Any recommendations for setting it up correctly? I mean, I didn't do anything special. My settings are pretty normal. It kind of just works for most projects. I do have inlay hints on tied to Control Alt, so I can Control Alt and see them. But yeah, I don't know. It all works just fine for me. Repeated Z's in the chat showed an example of what his problem was. So with list patterns, you can't have multiple slices. You can only what would this even mean? Give me the first and give me the rest. Where do I stop? Where you might want something like this, we don't support it, but I understand why you might want it. It's something like this, right? Where you could say, all right, so I want to match on some number of elements at the start, a 1, and then give me the rest of the elements. You might want to do that. We don't support it yet. We have talked about it. We're thinking about how best to support it, but we don't support it at the moment. All right. We have 7 more minutes of question time, so you can please still ask me questions, and I will be here for that time. Have I eaten yet this morning? No, I have not eaten yet this morning. I've had some tea, but I normally don't have breakfast. I go to lunch. Are there any good suggestions to dive in the new stuff coming with source generators? I feel like current integration in Visual Studio makes it hard for people who don't know much about it to get into it. So documentation for source generator authors is something that we're a bit lacking on. The best example, the best document that we have at the moment is I have a tag for it somewhere. Incremental generators, is that what I called the tag? I don't remember. There's a document that if you go to .NET/Roslyn and you search for incremental generators.md, you'll see a markdown document with the current design philosophy and how you approach incremental generation. It is a tough topic, right? Generation is not something that is particularly easy. We know that there's definitely some improvement to be made in the generator authoring experience, but to be entirely honest, we don't expect most people to be writing generators. We expect most people to be using generators, and so that's where our focus is mostly on, is making sure that the consumption experience for generators is good. Um, Turing Machine asks, wouldn't it be scary to have that dot dot slice value dot dot slice pattern built in? And absolutely, yes, it is scary to be built in. That's one of the reasons why it's not built in, because putting multiple slices, that's not a, this is a fairly simple desugaring, right? It's okay, check the first element and then call the slice method on the rest. Or if you have a slice pattern followed by, you know, bar first, right? If you did this, that's again fairly simple. Check the last element and call a slice method. A linear search algorithm that does dot dot and then an element and then another dot dot. That's way more complicated, and we are somewhat concerned about potentially including that in the language, and whether or not that's too much hidden magic, and it's going to be so much of a performance penalty that people will stay away from it and be scared of getting something they didn't realize they were asking for. All right. Brainiac asks, what is your opinion from a language designer perspective when people say C# has become a bit bloated with every release, and you would have 5 different ways of implementing something that in other language JS only has one implementation, like timers? Is that something your time considers when making a choice if something makes it into language or not? So absolutely, we 100% consider everything about does this thing adds a new way of doing this? Do we want to add it? And usually we say no, right? For most requests that we get on C# Playing, there are thousands of requests where we're never going to get to most of them, and many of them we're just never going to do. Period. And it's a delicate balancing act. For example, list the collection literal syntax. Do we have collection initializers? Why don't we just improve collection initializers? Why don't we make those better? And one of the things that we're going for there is we're going for consistency with the rest of the language. So list patterns, for example, they don't look like collection initializers. We tried for a very long time. We spent several months trying to come up with a syntax version of the braces that worked like this. So you could say that to get an empty array, and you could say this, a or bar first, dot dot bar rest. We tried to get this into a shape that it could actually work, and we just couldn't. We ran into too many edge cases, too many problems with confusion with property patterns. And so we said, all right, we can't make these things look exactly the same, and so I guess we'll do the braces, because the square braces, because square braces at least line up with indexing and they line up with array creation. So now we want to introduce what we call the equivalency principle. So when you do something in one area, it should be a similar syntax to do it in the other area. Object like recursive patterns look similar to object initializers. We would like list patterns to look similar to list initializers. They don't today. Collection literals will help us solve that, and they will help us solve other problems. And yeah, so we generally we're very judicious when we add new ways of doing things, and we try to only do it when it's necessary or when it's reducing a significant amount of bloat. All right, Tio asks, thoughts on active patterns. I am the champion of the active patterns proposal for C#, so you could say I'm a huge fan. I would really like it. That's not my cat, that is the siren. I live somewhat near a fire station. Okay, so what is my favorite food? Fried chicken. Absolutely love fried chicken. All right, I will take a few questions from the YouTube stream or the Twitch stream. I don't know which these are coming from, but I can see them both. Trace asks, are you thinking about something to make calling constructors of records with a lot of params more elegant, like we have for required now. I think required and object initializers are that. I'm not exactly sure what that's what we want. That's why we want to have required parameters, so that you can avoid constructors. So I'm not 100% certain what else you're thinking of there. Jay Cox asks, the LTM notes talked a few weeks ago about improving semantics with nullable value types. What are the improvements that have been discussed, and have there been any further discussion on it? So that's one of the working groups that we have. I'm not totally up to date on what that working group is doing. I'm not part of that working group, but that working group is publishing notes. So if you go to C# Lang and you go to the meeting notes folder, there's a working group subfolder, and there's a nullable improvements, something like that, subfolder of that. And you can see their notes. I believe they've met twice or so and have talked about a few issues. So you can see the current status of things there. Mizard X asks about parity. What about yield return in a lambda? I'm not aware of anyone championing that at the moment. It is certainly an interesting idea that I don't think is a bad one, but it is not currently a priority at this time. Let's scroll up. So our auto default structs coming. That was C# 11. It's out today. You can do it. So let's see. Call Dude asks, unless I misheard you, you mentioned improvements to where T new. What are those improvements? What would those improvements be? And this is the last question I'm going to have time for because we are at time. So what are the improvements? We don't know yet. We know that we want to build them on static abstracts in some fashion, but we don't exactly know how we're going to do it yet. So that is something that will come at a later point when we figure it out. It still needs to be designed. All right. So that's all I had, folks, today. Hope you have a great rest of the conference, and I will still be around in Discord, in the Solution1 chat, in the Roslyn channel, in help channels if you have more questions for me. See you all.